Welcome to the Byrne-Wheeler Report. On today's show, we'll discuss my impressions of the North American RISC-V Summit, discuss Nvidia tipping BlueField 4 at the recent GTC Washington, D.C., and talk about the report that Intel's considering acquiring SambaNova, and we'll talk a little bit about Amazon Trainium too.
So, Joe, you attended the RISC-V Summit last month. What jumped out at you there?
Yeah, so there were, two things that jumped out at me. One was Google gave an interesting keynote presentation, and then I was surprised to see a lot of Chinese IP vendors present, and really just to see what they're doing and realizing that some or all of them are on par with some of the better known Western companies.
What did Google talk about?
What was really interesting was Google talked a lot about their porting software to ARM. So, from that, in fact, I saw a story on the Register, the Red Top Tech tabloid, where they made this point about how they talked about ARM, but the whole point of talking about their experience of pointing to ARM was like, ergo, we now know how to port to RISC. So some of the little factoids they mentioned were they have like 100,000 software packages, and they saw the key value to RISC-V as being customization. And just to kind of go on a tangent here for a second, I talked briefly to someone from ByteDance. They were, the company behind TikTok, and they had a workshop where they were advocating for a couple instructions to be added to the vector extensions to make video processing work better. And I said, like, don't you just send that off to an ASIC or something to do? It's like, yeah, we do, but for talking head videos such as ours, where there isn't a lot of motion between scenes, that software worked fine. Just a couple basic instructions would really help the throughput. So, I think that's one example of customization, and then there's broader customization that you can do. But ultimately, Google wants a server SoC and a standard server platform specification to be defined. I can go in a little bit more about their porting effort if you want.
Well, actually, just on the topic of RISC-V servers, where is the consortium in terms of developing specifications?
So, the problem is it is a consortium. There are a lot of committees doing a lot of different things, but completed RVA 23 is out, and RV is RISC-V and A is for applications processors. The general consensus I've seen is that everybody wants compliance with that, and that says you need to have the vector instructions in your CPU, and you have to have hypervisor extensions and a bunch of other things. They're working on like some of the basic boot, like UFI and ACPI, but the next step, I think, which is underway, is this server platform specification. And I think when that is ready, then so maybe, to put a time frame on it, maybe like a year from now, we'll start talking RISC-V servers of some sort, perhaps with customization for some special feature.
That's not too far out. And so, yeah, it's interesting because Google Microsoft, Amazon, they've all done a lot of work on ARM-based servers, right? So that porting effort should very much inform any future moves to other RISC architectures. And
Meta is acquiring the startup Revos, which was, it's not entirely clear what they're doing, but they talk about SIMT, so that would be GPU-like programming model. They've been involved in a lot of the server-related committees. So, it sounds like they're doing something kind of like a RISC-V compatible GPU, or like combining that capability with server processing, either in one chip or like just kind of as complements. And Google clearly is involved, as they were given this keynote. So I think it's something everybody's looking at. Plus the Chinese are, they kind of have a mandate to go homegrown.
Were there any major product announcements there?
You know what? There were product announcements, but some weren't exactly new, and some I wasn't sure how new they were. So, for example, I recently on XPU.pub had an article about how TensorTorrent, they've licensed their cores, but now they have an official licensing business. So that was announced just before the summit, so that's kind of an announcement. Shantia is a Chinese company associated with Alibaba and the Demo Academy. They talked about their C9 CPU, which is new. I don't know if it's undisclosed previously, though. SpaceMit, another Chinese company, and yes, it's pronounced SpaceMit, not Space MIT, talked about a forthcoming CPU, which I think they put some press out in Chinese before. And Nuclei, which I'll have a piece on XPU.pub, announced a version of their high-end 1000 series. But that's sort of been out there for a while. But this seemed like the first kind of official disclosure.
So what's kind of the state of the art now in terms of high performance CPU cores on RISC-V?
So the highest performance, at least on paper, Sci-Fi was early with the P870. I'm not sure how much they're pushing on the gas on that for now. TensorTorrent is high performance. So kind of the standard benchmark the RISC-V community, at least on the applications processor side, has gravitated toward is Spec Int 2006. And so they're hovering around 20 spec ints per gigahertz. So I would say in that neighborhood would be the P870, the TensorTorrent Ascalon, the Cusco from Condor Computing, and the Akiana 5000 series. So these are
what
all
would be a comparable ARM core?
So a comparable ARM core would be like a Neoverse V2, that neighborhood.
Okay.
So kind of like a generation old or 1.5 generation old top performing ARM core. So
yeah, N-1.
Yeah, kind of an N-1, but pretty darn close. I think there's just a few more knobs to tweak to kind of get up to kind of that leading edge from ARM. In server processors, you tend to dial back the clock rate a little bit. So
yeah,
kind of depend. Like if the RISC-V implementations are a little more power efficient for some reason, they might be able to dial the clock rate up, and so you kind of neutralize the IPC versus clock rate. So it's not clear where it's all going to fall out.
So are any of these folks doing test chips with hard cores or at least test silicon with their cores?
Yeah, so it's an interesting thought. So TensorTorrent has like a reference chip, but they should probably do something that would be kind of closer to a finished product and that could actually potentially have some utility to it. And these tests are going to be, they're looking at like 8 cores. I think you could probably go a little bit beyond that. So not server, because Google's like, we want minimum is 64 cores. So maybe not a 64 test chip, but something where it's smaller than that. But then you have like real Ethernet ports, so not giggy, but say 10 giggy or multiple, and like a full PCI, like enough PCI to hang a GPU off it. I think that would be a lot more useful than something smaller.
The other big challenge going to like 64 cores is the NOC, right? I mean, you can't just have a simple NOC going to 64.
Yeah, now supposedly all these companies have a cluster interconnect, and most of them say they have a NOC interconnect, but Arteris is there and is partnering with some of them. I think that is doable, but that's one reason why you'd want to have more than 8 cores, because I personally, just spitballing here, I think it would make sense to have 16 cores where you have 8 clusters of 2 cores, because that way you're showing like, hey, we can have 2 CPU, more than one CPU in a cluster, and then you show a NOC, or a kind of the next level interconnect where you connect multiple clusters, and then you would have peripherals on the side. Like, I feel like that would be a better proof of concept than having a single cluster, just to get to that specific point.
How about chiplets? Are any of these companies productizing chiplets?
Yeah, there's some talk of chiplets, and I don't think there have been any specific announcements around that, but I would expect TensorTorrent to have one. And Ventana, since inception, has talked about chiplets. I think they had a lead customer that wanted them. It may be too early for them to have a chiplet given their technological progress and the state of their funding. But coming back to Google, they mentioned a few things that they learned in porting from ARM. So the things that you would think would be gotchas really weren't gotchas. So x86 has strict memory ordering and nobody else does. And they said, like, out of all these cases, they found 3 instances where that was a problem. And it wasn't clear that it shouldn't have been coded around in the original code. A lot of the issues were in the build files. So they have they have path names that reference the specific architecture. That seems to be the dominant thing, and then test cases. And as far as, actual architectural differences, people do FPUs and vectors a little bit differently. So, that's where ARM versus x86 needed a little bit more attention. But they do think that AI, so Google Gemini, will help with future porting, not necessarily on the vector processing in the short run, but on test cases. And then you can automate other things like renaming file names and paths and stuff like that. And the next thing, I brought up was the Chinese companies, and just kind of recapping. The first surprise I had was that they were there, and I asked a company, why are you there? It's like, well, we have customers in China, and we want to get more in. We want to get some in North America, and I didn't really have the heart to tell them that this maybe isn't the right environment for them to be pushing their technology into the U.S. market, from kind of a geopolitical sense. Plus, there are alternatives. So just to kind of talk a little bit about the companies. So the Xuanti is affiliated with Alibaba, and I think they released their cores to be open source. So there's T-Head, which again I think is affiliated with Alibaba, but there's some others that have taken that core. Then SpaceMit takes an open source core from, forget the name of the college, it's something like Shangxian. They presented it at Hot Chips a year ago. And Nuclei, their management came out of Synopsys on the ARC side and Marvell on the CPU side. So they have a lot of experience doing cores, and they're kind of they're comparable to Andes or maybe Sci-5, but based in China. So pretty big portfolios. They've got a lot of customers and are shipping product.
So Joe, I know you didn't attend in person, but you were watching what was happening at Nvidia's GTC event in DC last month.
Yeah, so that's true. It was in my neighborhood, but I did not attend. I did watch the keynote video. I think where Jensen talked about a few things that had been disclosed previously. They also revealed BlueField 4, which is their smart NIC design. They didn't talk about it, but from the pictures, we can infer at least one significant thing about it.
Yeah. It's really not a unique design. It appears to be essentially a Grace die and a ConnectX-9 die that are co-packaged. And the interesting thing is it's not even clear they get any benefit out of co-packaging them because they're just using PCI Express to connect the two. And so there's no coherency there. I'm not really sure why there's any benefit in co-packaging. And then Grace has PCIe Gen 5. So to get 800 gigs of throughput on the network side, you would have to have 32 lanes, meaning kind of dual by 16 PCIe ports just to get enough bandwidth between ConnectX-9 and the Grace CPU. It seems like a suboptimal design, but it didn't require them to tape out anything new.
Right. I mean, somebody must have asked for this, don't you think? Because previously their public roadmaps, BlueField 4 was conspicuous by its absence. It would be, BlueField 3, then a blank, and then... So it seems like it's a recent addition, and maybe that's why we don't see silicon for it. I don't know, what do you think?
Yeah, I think some customers wanted the DPU essentially on the front end side of the network, right? For isolation and for many reasons, probably where ConnectX-9 just doesn't have sufficient intelligence for that front end application. A good candidate would be OCI. Oracle is suddenly kind of on the same, but now a hyperscaler, right? In terms of the scale of what they're building. So they'd be a good candidate as to, what customer was sort of asking for that because they don't have their own DPU in-house.
Right, whereas other companies, Google and Amazon, for example, have their own DPUs with proprietary security and other features, right?
Yep. Yeah, I mean,
And
Google
meanwhile,
has,
ConnectX has picked up some functionality versus previous versions that had been in BlueField, hadn't it?
yeah, I mean, it turns out that RISC-V complex was there all along, and they just never really talked about it. So if you go back and dig into ConnectX 7, you'll discover that it actually had that, I forget the three-letter acronym they used for the event processing unit or whatever it's called, but it was actually in there in ConnectX 7. I think it's 16 memory serves. So that was already there along with the ARM cores in BlueField 3. And so really this is just kind of bringing back the ARM complex, but adding a lot of horsepower, obviously, because now it's 64 ARM cores. So you've got, essentially a server class processor for your SmartNIC, and that opens up a lot of possibilities of offloading functions kind of to the network.
Right. And I do think, speaking of RISC-V, this is the kind of infrastructure where RISC-V is relatively well positioned to enter because you don't have the dependence on the software ecosystem, so you don't have to do as much porting and testing and so forth. And then the opportunity to customize. So, for packet processing or what have you, there may be, some special hardware that you could add and create a custom instruction for.
Yeah, I mean, on the other hand, you might want to actually boot Linux on that thing, right? In which case we get back to the discussion about server platforms and having a RISC-V server spec, essentially.
Right. I mean, it depends on what boot Linux means. I mean, like RISC-V can boot Linux, but it's sort of everything else. It's like, do you have all the packages you need to do your thing? So if for some reason you need a VPN on a management port, like, do you have all the dependencies been fulfilled to do that?
Yeah, so it seems like the DPU space is we have these very highly programmable platforms like BlueField 4 or Excite Labs E1 DPU.
Right.
Full ARM compatibility, or you have something like AMD's Pensando architecture where it's a P4 pipeline. It's programmable packet processing, but it's not really a powerful general purpose processor.
So I think it really depends on where the emphasis is. Is it more on the data path side where you want the programmability, or more on the kind of like the control side?
Yeah, exactly. They'll fill the hole with this kind of fast time to market solution for BlueField 4, and then I guess if there's enough volume and customer demand there, they can optimize something, and they could potentially shift to using an NVLink interconnect, for example, even if it's a multi-die solution. But for now, they have something that they can kind of quickly bring to market.
Right.
I didn't see much else from GTC. I mean, it was kind of the refreshed roadmap. Few new details on Rubin, but some nice product mechanical samples to show and that kind of thing.
Right. Yeah, the super chip, which is about the size of a compact PCI blade. Those Rubin packages look really, really big. I mean, I think we're used to seeing switch chips that are like saucer size, but we're getting up to like dessert plate size packages. Yeah,
these are pretty massive, and those are just the regular Rubin, not the Rubin Ultra, which is 4 die. So they're going to keep getting bigger.
Right. I didn't notice that they were not the 4 die version. Some other news that, Bob, you emailed to me one evening last week was there were reports that Intel is considering acquiring SambaNova, which from my perspective was surprising. SambaNova being NPU company, NPU meaning a neural AI processor company, and that's something where certainly Intel has its own projects and has done a number of acquisitions in that space as well. What struck you, Bob, about it?
Yeah, I mean, not clear given they still have the Gaudi IP from Habana Labs, which they said they were going to integrate into the data center GPUs going forward. Not clear how yet another AI architecture would sort of fit into their overall product offering. So it's a little bit of a head scratcher to me. SambaNova, I paid attention to for a number of years now. They're different because it's a coarse-grained reconfigurable architecture. It's basically a data flow architecture, which, if you'll recall, Graph core is also a data flow architecture, kind of a different animal from, a GPU altogether.
Yeah, certainly very different from a GPU.
Yeah, it mixes SIMD units and memory units into this array structure. And there was pretty good talk last year at Hot Chips by one of their architects on the SN40, which I believe is the current generation.
Yeah, I believe that's current as well.
So there's some good information out there on it, good level of detail from a technology perspective. It is very different from anything that Intel would have in their portfolio, but again, how do they position that against what they already have in their product offering? And particularly with this recent news that we talked about, that they have this Crescent Island GPU for next year. Are they thinking that the AI space is looking more and more, heterogeneous, and that there are going to be requirements for multiple architectures to satisfy different workloads? I'm not quite sure what the angle would be.
Yeah, although, I mean, that would be kind of a reversal, as they've stopped developing the Gaudi series to concentrate on their GPU, their data center high-end GPU product, which the next one would be Jaguar Shores. I would say about CGRA, there is a flavor of CGRA in a lot of NPUs and GPUs. So like even within the GPU and in the forthcoming Jaguar Shores, which borrows a bit from the Gaudi, is they do have these tensor units or these big MAC arrays. My sense is they do have a bit of a CGRA flavor into that they're systolic arrays. It's not really talked about that much, but I think they can do more than just route to the nearest neighbor, but you can map a certain data flow into them. So it's not totally foreign to do CGRA, but to do such a pure CGRA is definitely different.
Yeah, so I guess there could be an IP angle there if they weren't going to actually carry the product forward. That's one possibility. And then you get into the question of valuations and what exactly are you buying.
And then also SambaNova, they forward integrated, they created their own system in their own rack, and then they offer cloud services. So there could be some experience there that Intel's looking for. The fact that one of their major investors is the Intel CEO kind of demands some explanation and clarity just to make sure everything's above board.
Yes.
And I think also, if we have the Crescent Island and Jaguar Shores in flight, we had the Habana acquisition that was completed, and that was kind of a mulligan for the earlier Nirvana, but then they moved away from it. I just think Intel has to be a lot more clear about what they're trying to accomplish and the steps they're taking to ensure that whatever direction they choose will be successful and not abandoned. Like they need some kind of integration or bigger strategy that they roll out at the beginning and hold themselves to account to. Otherwise, it could be a disappointment.
Yeah, I agreed. So another piece of news that rolled across recently was there's an interesting interview on CNBC with the head of AWS at Amazon. They talked about this Rainier data center they're building, or have built, I should say, in Indiana.
Right, despite the name, it's not being built in Washington, it's being built in Indiana.
Correct. And the astonishing thing is the speed. The construction began, I think it was September 2024, and this data center is already up and running. And the astounding thing is they have about 500,000 Trainium 2 accelerators already deployed in this data center. And this is specifically for use by Anthropic for both training and serving their models. And they're targeting 1 million Trainium 2s in this one data center by the end of this year, meaning the next couple of months. So it's just astounding the speed at which they're building and also the scale. And this is the largest scale use of their internal Trainium processors or accelerators. And then they mentioned that Trainium 3 would be launching in the next few months. So Trainium 3 is coming fast.
Yeah, so we could actually compute how many servers if we wanted to, because I think they put 16 Trainiums on a blade. So you take 512 divided by 16. That'll tell you how many shelves or whatever. And figure out how many per rack and figure out how many racks that is. But it's a lot. It's crazy to think these installations where, you know, 500,000 or 1 million is the kind of the standard unit of standard increment for size.
Yeah, and I think at full capacity this is supposed to be 2.2 gigawatts or something.
Yeah, so it's a lot. I took a look at a Trainium 2. You know, in terms of performance, it looks like, you know, roughly speaking, it's about 1/3 of a Blackwell in terms of, like, say, in terms of raw flops, floating point 8 flops, and in terms of chip-to-chip interconnect. So in terms of, and I don't know what their utilization is when they're actually running, because it can be pretty low on a GPU architecture, and their architecture is one in which they'll have 16 of their neuron cores per chip. That may be 8 per die. I think it's a dual die chip, which you should be able to see from the B-roll here. And they use a systolic array to do the heavy lifting, but they have vector processors. Then they added some SIMD, so also vector processors that can be programmed by, say, Anthropic for, you know, proprietary functions. And then at the higher level of the chip, so in parallel with the neuron cores, they have these, they call them collective communication cores, which I assume do collective operations as well as orchestrate communication amongst chips in the cluster.
Yeah, and they've had a pretty simple Taurus interconnect, but in the next generation, they're moving to a switched interconnect for the neuron link, chip-to-chip interconnect. So that's going to be a big step up in terms of the scale-up interconnect.
So that implies you'll have to develop a switch to do that chip-to-chip.
No, it's the switch is coming from Astera Labs.
Okay, so Astera will do it. You know, meanwhile, Anthropic, I think they're also running loads on Google TPUs. I think they have some running on Nvidia as well. So, you talk about diversification. I think they're at the forefront of the big AI providers looking to gain some independence.
Well, and then looking at it from the AWS side, they just announced this massive deal this week with OpenAI, but that's running on quote hundreds of thousands of NVIDIA GPUs.
Right.
So there are people looking for capacity and people providing capacity, and it's coming in all forms, and it seems like OpenAI is getting it wherever they can find it. And so, yeah.
With that said, OpenAI, have they disclosed anything other than using NVIDIA-based systems?
Well, there's this deal with Broadcom as well, although it's not clear exactly what that entails.
Right. That's a future system on a proprietary chip, though, right?
Yeah. So anyway, it's hard to even keep up with all of the deals that are flowing right now. But I thought the interesting thing about the Amazon Rainier was the fact that it's real and operational and running today.
Yes, and very quickly.
Right, and very quickly.
Right.
So pretty astounding.
Actually, going back to OpenAI, they do have the agreement to run some workloads on forthcoming AMD-based systems. So they are
true. The
doing
MI450
some diversification as well.
Yeah, on the MI450 generation.
And I think, if a company like AWS doesn't have a major customer on Trainium 2, then you have to ask why they're bothering to do it. So, it's important for these proprietary designs to actually have customers, ideally external. Google runs a lot on their TPU, and they seem to be able to justify it. But, everybody else, they want to have their own, but people have to find them useful.
Absolutely. But of course, there's always also the issue of just having some leverage in dealings with NVIDIA and not being entirely beholden.
Right. Well, on that note, let me just say thanks to everybody for joining us today. And for more information, see wheelersnetwork.com and XPU.pub. If you have any questions or comments, you can put them below, and you can help us out by telling 4 friends about this if you enjoyed this. And until next time, be well.
It's all about the panties, baby.